a particle P moves in a straight line at time t, the displacement is x. And we're given this equation. I'm going to write it because it looks nice. Find the velocity and acceleration of P when t equals 0. So this is this stuff about using calculus to deal with this. If this is the displacement, then velocity is equal to dx by dt. And we've just started doing some of this stuff, so we're getting practiced at it. Differentiate t cubed, and we get 3t squared, but of course we'll multiply this by 0.06, so that's 0.18 t squared. Differentiate t squared, and you get 2t, but we've got 0.45 there, so minus 0.9t. Differentiate t, and you get 1, so we're left with minus 0.24 at the end of that. As I'm in a kind of differentiating mode at the moment, I'm going to carry on and do this again, because the question does want the acceleration, which is what we get if we differentiate velocity with respect to time. So if I differentiate this again, t squared will go to 2t, and 0.18, so that's 0.36t, 0.9t, so that goes to minus 0.9, and there we go. So we've got our expressions for displacement, velocity, and acceleration. The question said, find the velocity and acceleration when t equals 0. So if t equals 0, v is sub-zero into that, and we get minus 0.24 meters per second. And the acceleration, put t equals 0 into that expression, and we have minus 0.9 meters per second. There we go. And that feels a little bit crazy, doesn't it? Because what we've got there is 6 marks for just differentiating twice, really. I mean, the last bit, putting t equals 0 into that, was trivial. But you see how things work, that the calculus bit is considered a big new skill for you at this stage, so it's loaded with lots of marks. So just for differentiating we get one of that. Right, the value of x when p, we need to find the value of x when p has its minimum velocity and the speed of p at this instant. Okay. Now this is some of the stuff that we haven't maybe talked about that much yet actually, but the minimum velocity of p. The minimum velocity would come at the point when its acceleration is 0. Okay, because it would come at the point where we're changing from kind of accelerate. No, which would it be? If it's minimum velocity, it's changing from decelerating to accelerating. So as the acceleration crosses from being negative to positive, when it's 0, that's the point it has its minimum. Once it starts being positive, the velocity is going to increase again. So the minimum velocity occurs is when the acceleration when dv by dt equals 0. So we're interested in what happens when dv by dt is 0. That's 0.36t minus 0.9 is equal to 0. If we rearrange that, that's t is 0.9 over 0.36. So we get a time of 2.5, 5 over 2 seconds. But that's not what the question asked us. The question said, find the value of x when p has its minimum velocity and the speed of p at this instant. So having found this 2.5, we need to plug this back into other things that are going on. At this point, x equals if t is 2.5, x would be 0.06 times 2.5 cubed. I can't see it all. Minus 0.5 times t squared. Minus 0.24 times t. So being really careful how we enter all of that into the calculator. I've come up with a figure of minus 2.475 meters. That's my value of x. And the velocity is that equation there, so 0.18 times t squared. It was minus 0.9 times t minus 0.24. That was right, wasn't it? Yeah. Which gives me minus 1.365 meters per second. I'm just going to be extra careful here. I'm happy with this one. The question said find the displacement, I think. The value of x, we found the value of x, but look, the question said, and the speed of p at this instant. So we've not quite got it there because we've said velocity is minus 1.365. So the speed of p is 1.365 meters per second. Whoop, the board's just decided to do a crazy thing. Back. There we go. So that's our speed. Must be a positive amount. Okay, the question didn't ask you for the velocity, it asked you for the speed. So you must make that into a positive quantity at the end. Really important for that final mark. Last bit, the positive value of t when the direction of motion of p changes. Okay. Well, the direction of motion of p changes. That means that the velocity changes from being positive to negative. That's what direction of motion changes would imply. If the velocity has changed from being positive to negative, well, at the instant that it changes, it must become zero, mustn't it? Because that's what you get between positive and negative. So actually what the question is saying is find the positive value of t when the velocity is zero. It's another way of saying that, isn't it? So actually part 3 is saying when is v equal to 0. And it wants the positive value of t when that happens, so that implies that there are two values, one of which is negative, one of which is positive, and that's what we're looking for. Well, v is 0.18 t squared minus 0.9 t minus 0.24. And we want that to be equal to 0. We've got a number of approaches that we could take to this. What do you want to do? We could just plug it straight into the quadratic formula. That seems like a kind of sensible thing to do. So I'll suggest that. Stick it in the formula. I'm also thinking, looking at it, I'm a bit more kind of, if we multiply the whole thing by 100, we get that, don't we, as our equation, which then also has a common factor of 3. In fact, it has more than 3 as a common factor, does it? It has 6 as a common factor. Which would be, is that 15? And that's 4. So it starts to look like that. And does that factorise? Now feeling not sure that it does, which is a shame. It felt like it ought to. What would we have? We'd have 12. I can't think of two things. I multiply to give 12 and add to give 15. That's just not going to happen, is it? Oh, what a shame. Well, we could do it at that point. We could put it in the formula, or you could do it from that point. So if we forget about all that little bit of work that we did, t is minus b plus or minus the square root of b squared minus 4 times a times c, or divided by 2a, which is a horrible thing that we've got there. The question did say find the positive value of t. Now looking at what we've got here, the positive value has to come from the positive bit of the plus or minus, doesn't it? Because the minus would take us in the wrong direction. And so if we put all that together, we've got 0.9 plus the square root of 0.9 squared, that's 4 times 0.18 times, that's 0.24, divided by 2 times 0.18, and the calculator is telling me 5.25 seconds to 3 significant figures. And there we go, that's all we need to put for our answer. If you're interested, the negative one, I can't find it, is minus a quarter of a second. Well, it's the positive one that we're after, 5.25. There we go. Okay. Happy with that? Great. And that's maths.